So some in this problem, we're going to be multiplying some binomials. And the first part says find the product. And you can see that I'm multiplying a binomial times another binomial. That just means there's two terms times two terms. And if I look at this, I can write the answer down, right? This is the same as 3x squared plus a single factor of x plus 15x's plus the number 5. And I can simplify that as 3x squared plus 16x plus 5. So I can confidently write that down. And our goal is for us to get to where we can do that. But in the meantime, when we're figuring out what we're doing, and certainly to organize our work, we can use what's called a generic area model. This is a binomial times binomial. So I'm going to make a 2x2 grid. And in this grid, across the top, I'm going to represent the length and the width of a multiplication problem. So across the top, I'm going to go ahead and place an x and then a positive 5. And then down the side, I'm going to write a 3x and a 1. Now, the lengths of these, right, this is not drawn to scale because it's called a generic area model. But what I'm modeling here is the product of an x plus 5, an x plus 5 times a 3x plus 1 times a 3x plus 1. To do that, to get that answer, there are four distinct parts, four distinct multiplication problems we're going to do. The first one's pretty straightforward. I'm multiplying 3x times an additional factor of x. And when I do that, I get 3xx or 3x squared. Below that, I've got an x times the number 1, and 1 times x is just x. My upper right box, I've got a height of 3x. Well, this is still 3x tall. 3x tall times 5 wide, which gives me 15x. And then right below that, I've got a 1 times 5. This is 1 tall, 5 wide, so it's 5. So to get each of those, I multiplied the dimensions, right? The length and the width to get the area of each one of those individual boxes. Now to get my product, my final product, I'm just going to simplify this. It turns out there are two like terms, right? This 15x and this x are exactly the same term. So those two can be combined with each other. And the other two terms are going to stay separate. So what's my answer? Well, you can see I've got the 3x squared. And then when I add the 1x plus the 15x, I've got plus 16x. And then I've got the plus 5. So again, the exact same answer. Keep looking at this, think about this, and ask yourself, geez, how can I do this without using a generic area model? That's a good goal. The next one asks us to square a binomial. And this is a bit tricky because when you square a binomial, remember you're multiplying that thing by itself. So a lot of times when I see that I'm squaring a binomial, the first thing I'll do is I'll just say write two copies of it. I've got a 3x plus 1 times another 3x plus 1. So this helps me avoid the error of missing a part of the product. I can, again, I can model this with a generic area model. I think I've got enough room to do it right here. So I'm going to go and say it's the same thing times itself, right? What do I have? I have a 3x and a 1, a 3x and a 1, and another 3x and a 1. And again, there's four parts. 3x times 3x is 9x to the second power. 3x times 1 is 3x. 3x times 1 is still 3x. And then finally, 1 times 1 is 1. So what am I looking at here? Well, you can see the parts. There are two like terms like before, right? This 3x and this 3x are like terms. So those two can be combined, but the other two terms are going to stay the same. So I'm going to write, hey, when I multiply 3x plus 1 times 3x plus 1, or when I square 3x plus 1, I get the following product. I get 9x squared plus 6x plus the number 1.